question is great. The question is, I liked the way I did the annual compounding. Why are you making me do it a different way? Two reasons. One, I saw it happen a lot in the other class where they were, and I want to show you what they did before we actually do it. And it's an easy mistake to make, just so you know. What they did, it's an easy mistake to make. Ryan, you and I kind of did the same thing in a different way on yours originally. Excel, I think I've told you this before, Excel is very fast and very dumb. It will do exactly what you tell it to do, even if what you tell it to do is incorrect. And that's what these other students were doing. They were dragging too quickly and not realizing what they were dragging was actually the wrong thing to drag. I still do it to this day. If I'm working too quickly, I'll drag incorrect things, and I look later and I'm like, what the hell, that doesn't make any sense, and I go in and I'm like, oh, it's because I should have been D6, it was actually A6, something like that. The second reason is there's some good math involved in the answer to number 2 that I want to kind of focus on today, for the entire day actually, even with the next examples we're going to look at. So be patient, my friend, I appreciate this. Okay. So how did question number 1 go? Was it okay? Were you able to figure out number 1? Let's chat through number 1. So number 1 was on the monthly compound, and this is the work we did yesterday. And if you remember the formula that we used, which is going to be a little bit hard for those at home to see, but I can write it on the board. We ended up, so I'm just going to put some cells up here. If your $100 was in cell D6, so if this is cell D6, then D7 down here, we said was equal to D6 times 1.0017. That was kind of the formula we came up with towards the end of the class last time. And where did we get that 1.0017? Where did we get that from? I apologize if you didn't use these cells. You put whatever cells in that your stuff's in. Is that confusing anybody? I'm sorry. Hopefully it's not. So in other words, if you put your $100 somewhere else, just call it whatever you put it in D6. And then the next one will be D7. And then you just, is that okay? I know it's early, but I'm also seeing some panic looks, and I'm like, holy shit, I'm gonna speak. There. That better? Is that worse? Might be worse. I'm gonna stop talking about it. Where did the 1.0017 come from? Where did the Sophia?
0.02 divided by 12.
We have to, thank you, we have to compound monthly. So what the banks do, by definition, is they divide the 2% annual return by the 12 compounds that you're going to get over the course of that year. So with annual compounding, it's just 2%, which we'll come back to with the second question in the warm-up. But with monthly, it's 2% divided by 12. Now the trick with this, which was inadvertent, I didn't mean for it to be a trick. The trick with this is when you do that division, you get a crazy repeating decimal. It's like 0.00166666 forever, yes? 0.001766 repeating. So since you can't sit there and type infinite sixes into Excel, we rounded it off, yeah? So we called it 0.0017, and then we call it, and that became the extra interest. Who wants to remind me what the 1 is again? As I step on the screen. What's the 1? Sorry, there's a little dance. What's the 1 stand for, people?
It's accounting for the $100.
Thank you, yes, exactly right. And as I pull that formula down, the 1 is going to stand for whatever the previous amount was. You're getting 100% of the previous year's money, or the previous month in this case, previous month's money, plus the next month's interest, which is the 0.0017. And the problem with this is nothing. Mathematically, that's perfect. Financially, the bank will never give it to us because it's too much money. It's too much. Remember when we rounded up the interest rate? We made 0.00166666. We called that 0.017. The bank's gonna go, no. You don't earn that extra 1/10,000th of a decimal. You're not entitled to that. You're going to get exactly your interest rate. Now the exact interest rate is actually this. So your job in this one was to type a formula that represented exactly adding that interest into Excel. Who wants to come up and do it in my spreadsheet over here? Here, I'll get you started. Or walk me through how to do it. So I'm going to put over here the amount in account that the bank won't be pissed about. Account at the bank won't. I have a problem typing. Won't be pissed about. There we go. Okay, so you're starting with $100. All right, let's make all this dollars, I guess. Okay. What formula should I type right here, my friends, that guarantees I not only keep the $100 from the previous month, but also incur exactly the correct amount of interest? Who wants to tell me what their formula is? Be brave, my friends, be brave. Walk me through it, or just come up and type it. Oh, okay. Sorry, I didn't like this question, I'm sorry. When you hated question 2, I assume that meant you were okay with question 1. I apologize if you didn't like either. Well, let's build it together. What should it start with? There we go. When in doubt, type an equal sign. It's got to start with that, right? There. What do you think we should do? What do you think we should type next? Don't overthink this.
Parentheses.
Oh, we can use parentheses. I like this. What are you going to say, Colton?
I was just gonna say 2 divided by 12.
2 divided by 12. I like that too. Except not 2 divided by 12. 0.02 divided by 12. Is that okay?
Yeah.
Don't give yourself. The bank's going to like that even less. That's 200% interest spread over a year. If anybody finds a 200% interest rate account, please let me know. Okay. So 0.02 divided by 12. I like that idea, but give me your whole formula first. I want to hear Jonathan's whole formula. Give me both.
I'm rethinking it. Now
You're-
that I saw
no.
what you said.
What?
So I'm creating one right now so that I.
Oh, you're doing it. Okay, so you're going to use 0.02 over 12. Keep talking about this.
And then I was gonna try multiplying it. by
Yes,
2.
keep going. I love this. And then what else are you going to do? I like this. This is going to work.
And then I guess times the months.
You don't have to do that. Watch. Here, I'm going to do what you just said, Colton. Okay? So you said equals 0.02 divided by 12. And then you multiplied that. I'm going to put, I think it's going to work without, oh, piss, hang on. I'm going to put that whole fraction in parentheses just because I tend to default to do that. And I'm going to multiply it by the $100, right? Now the only problem with that, Colton, is if I press enter, what the hell? What happened to the other? I gotta add remember you gotta add in the previous amount as well. This is just the interest. We also have to add in the amount. So I'm just gonna edit your formula, Colton, by simply going plus E5. Does that see what I'm doing now?
Yeah.
So I'm taking the original amount, bringing it down, and then adding the interest I'm allowed that month by that, if that's fair. Is that okay, sir? And then I'm gonna drag that puppy dog down, and it should go all the way down. I want to hear yours too, Jonathan, in a second. Just I want to do as many ways as possible because I like having multiple solutions to these. Now, when you look at this versus this, do you notice anything as we go side to side? Let me make sure the camera can actually see this. I'm not sure we're zoomed in enough that we can. You know what I'm going to do? We're going to do this old school podcast format. There we go. I feel like Blair Witch. Josh! Blair, oh shit, you're that young. God bless us. Okay. You're with me. Like 5 of you are with me. I feel so old. Okay, so what I want you to look at is compare this column is the rounded amounts that we used yesterday. And this column here is the exact amounts. Do you notice anything? As the exact amounts go down, compare them to the rounded amounts. Do you notice anything? Hopefully you do. Are they exactly the same? No. What? They're close. I wouldn't say they're vastly different, but why are they different? If we did the same math, why are they different, Colton?
Well, I'm just curious about. I'm sorry, I'm good.
Oh, it's okay. Why are they different? We did the same math. Jonathan!
Because you rounded it to a decimal instead of using like a fraction or an exact.
Yes. This is the rate we use. This 0.0017 is the rate we used yesterday because we rounded off the rate. This is the rate we're using today. We're actually using the exact 0.0016 repeating. We just wrote it as a fraction instead. And that's why they're different. Did anybody scroll down to the bottom and see how the bottom looks at the end? It's not a crazy significant amount of money, but it's different enough. I mean, it's 122.61 with the rounded value versus 122.12, so you're off by about 50 cents. But that's 50 cents times how many bank accounts that are open. The bank's not going to overpay that. They're going to pay you exact amount you want. Stop me right now if this doesn't make sense, because we're going to look at this again in a different way. Because I think anyway, because I think, Jonathan, you were going somewhere different with this, and we're going to take a look at yours too. But I want to make sure we understood that first. Colton, that formula was awesome. I appreciate it very much. So in other words, you would write your formula kind of like, just in case you couldn't see what we typed in, if your $100 were in D6, I'm going to leave D6 as the reference for all of our formulas, if that's okay. If that was where your $100 is, your new D7 would be 0.02. I'm going to write it just like it looks like in Excel, actually, because I was going to put it over 12, but you can't put over Excel. It would be 0.02 divided by 12 times D6. Thank you, plus D6, because you have to add the principal, is what it's called, before you add in the interest, or when you add the interest. Is that fair?
Yeah.
I love it. I love it.
So I was just kind of curious.
Oh, go ahead.
Excel, how long does it keep that 6 repeating? Like,
oh, the float point. Ask me at break, I'll Google it. I used to know the number, and I don't. I want to say it's something simple like 100 decimals, but I don't think it's that simple. I think it's something like 36,692 or some stupid number that I used to have in my head that I don't anymore. I'll Google it at break. It's called the floating point, and it does fart out after a while. There's a point beyond which there's not enough RAM to keep that many computations going. I'll look it up for you. I just don't know off the top of my head. There's enough. Enough for financial usage.
yeah.
But rounding off to 4 decimals is definitely not enough for financial usage, so you've got more than enough that you need. There's lots of limitations Excel has, none of which impact us in any meaningful way. Okay. Let's type it a different way. Now, if you like that one, you can just tune me out for the next couple minutes. Like, Sean, I like that. I don't want to see what you have to say. It's okay. But Jonathan, I can't help but think you had a different way just because the first thing you said was use a left parens. So what I'm going to do is I'm going to create a new column next to this one to do it a different way. And you get to pick which way you like the best. Okay, amount in account, the bank will be pissed about, and we'll call that squared. So we're doing it a second time. Okay, there we go. So we're doing it a second time here. I'm going to start with $100. Okay, Jonathan, I'm in column F now, but you can just tell me what to do. Equals
Left parentheses, 0.02 divided by 12 plus 1. That way we have our 1.02%, and then parentheses times the previous cell.
Everybody see what just happened? See what just happened? It's pretty slick. It literally is Colton's formula, but like we did yesterday, I forced you to write the formula or only had one variable and not two. And this is the quick little arithmetic way of doing that. And we can actually drag that down. You'll see they're exactly the same thing. They're not formatted like money yet. I'll format it like money so you can see it's exactly the same thing. There we go. All right, there you go. Compare them all the way down. Compare them right the way down. 67, 84, 84, 101, 101, all the way down. So I'll give you that formula too. It is, just so you know, it's Colton's formula, written a different way. It's the same exact formula written a different way. And I can tell you like that, but as soon as you realize what was going on, you're like, oh, okay, I got that. So if you want to see it a different way, here's another D7. You can put the 0.02 divided by 12 plus 1 times D6. And that way you only need to have D6 once. You never have to have D6 written again. If I may, an alternate, if that's okay, exactly the same thing, put the 1 first. That might be easier to kind of process, maybe. It's not mathematically any better than either of the other two. All 3 formulas are the same thing. They just all do the exact rate versus the rounded rate. And that's the key, is the bank's not going to give you more money than you're entitled to. By this other. Okay, about what part? Let's talk through it.
So I actually got something completely different.
Can I see?
Yeah.
Yes, thank you.
I just changed.
You're giving yourself too little money. Watch this, if I may. I'm going to use Hilda's example. This is a perfect example, if I may. Okay, so Hilda, the bank won't be pissed about yours either because they'll be giving us too little money. If I may, I'm going to put this over here. Make this cute. Okay, it's not cute. I lost myself in the superscript. Hang on one second. I'm kind of ridiculous about this kind of stuff. Okay, so you started with $100, yes? Love it. And then you did 1.0016 times that amount right there, yeah? Now notice, if you look at that, that's only giving us 16 cents where we're entitled to more than 16 cents. And that's because what you did was, you looked at this number here, and you said, you know what, I know that's 0.0016666666. Bank, you get to keep all those extra sixes, you just give me one of them. Don't cheat yourself. That's not enough sixes. So watch what happens if I start adding sixes. Watch what happens when I start adding sixes. So we're gonna add 1 6 first, make it 6 6. Okay? Oh, we got some more money. See, we got some more money. Let's add another 6. Oh, we got some more money. You see, every time I add a 6, I'm getting 1/10. How am I going to say this correctly? Every time I add a 6, I'm regaining some of that lost fractional currency that you threw away by only having the 1. Does that make sense?
Yeah.
So really, to answer kind of Colton's question, you could literally type this in a formula form as just come up here and do this.
That's right, yeah.
Did you? I mean, I guess you can. Let's just see what happens. I'm curious now. Oh shit! It doesn't like that. Too many 6s, maybe? Start with a letter or letters.
Maybe just get rid of 1.
Okay, we'll take 1 away. If it still does it, then I think we may have your answer, Colton. Okay, it doesn't like all those 6s. So, but you see, for this and other reasons, I think the sensible thing is just to write it as a fraction, 0.02 divided by 12. Does that make sense?
Yeah.
Thank you. Thank you for that question. That was a wonderful one. But the point is, the more 6s you have, the more money you're going to be getting back, and the more close to correct the formula will be. So thank you for all 3 of these. These are wonderful. You buying this, people? I'm sorry. As a head cold, this is gonna be awful. I'm sorry. It's math. Math for cold. It's like bam, bam. Okay. All right. I'm gonna pause this for a sec. Those poor people, my nose was right in the camera before.